Well, good evening. Interesting point of view. This video is actually being recorded in my home, and so you can kind of see that we've got different background anyways. You can see some nice pictures on the refrigerator. Of course, we have letters because we do have a 4-year-old and we're working on letters and phonics and stuff. So, anyways, moving on into our last topic set of kind of really big ideas when it comes to motion. This one's on momentum and collisions. Okay. And I think that momentum's going to be kind of a good one for a lot of you. You're going to really start to see how things are kind of piecing together, and we're tying everything right back into that Newton's laws of motion. Okay, so a lot of this was all groundwork laid by Newton. I think this is one of my favorite things about momentum. You can actually see momentum in a lot of different areas. We usually tend to see it in a lot of our sporting events, where we see a lot of different changes of momentum. I chose to pick a picture of a pool table and a pool ball because I think this is the ultimate when it comes to the kind of collisions and momentum and how you can see everything play together. And I actually used to play a considerable amount of pool, so it was kind of fun to look at this. I think that's every physics teacher likes to play pool. But ideally, we have here our cue ball, and our cue ball is the one that we're going to give our initial amount of energy to. Okay, so we can tie this right back into energy. So we give it some energy, which means we're putting it in motion, and once something is in motion, it has momentum. And the momentum of that cue ball is going to impact all of these guys right here, and it's going to make them all scatter and go in all different directions. And so we're transferring our momentum from the cue ball into the rack of balls. And so the more momentum we can put into it, the more we get out of it, which really says a lot about how we're going to kind of calculate momentum. And momentum, as Newton put it, was the quantity of motion. It was the way he wanted to actually talk about motion. The other interesting thing about that is that the way that Newton wrote his laws of motion is he actually wrote it from the momentum point of view. And so he actually looked at that, and we'll kind of tie in how that kind of fits when we get into the other topic areas. But again, momentum, something that we always talk about. In fact, you'll even hear it on the Sunday football games when they talk about, the size of a lineman and that it's going to take a lot of momentum to break through that line. And so momentum is really one of those words that we have a tendency to use a lot. And I think everybody has a core understanding of what that word means because it talks about, the amount of motion that something has. And that it relates back to kind of the size or the mass of the object, which is going to be kind of a key thing. And when we also look at momentum, I know a number of you have already had a chance to go around back by the printer, and you've seen this. This is called a Newton's cradle. And Newton's cradle, it said, is nothing more than a way to talk about conservation of momentum. And typically what we do is we take one of these balls that are hanging here and we pull it back here and we give it an amount of potential energy, and then we release it and it comes flying back in here, and all that energy gets transferred. Not only are we transferring energy, but we're also transferring the momentum. And so we look at this collision, and the momentum and the energy transfer into this one, which then transfer into this one, which then transfer into this one, which then sends this one shooting out. And then we end up with, if everything is identical, the same amount of momentum on both sides of the pendulum, essentially. Okay? And so that's, again, how we kind of look at momentum. So, big topics here. We're going to be looking at a conservation of momentum. Okay? So that's one of our topic. We're also going to look at this other thing called impulse. And impulse is back relating us to forces and momentum, and so we'll see that. In fact, Newton liked to talk about both of these things in terms of his laws of motion. And collisions. And collisions like this and how they behave. Okay? And so really these are the big topics when it comes to this topic set. And you're going to see that this one will go pretty fast. We will do a little lab activity. We'll probably put some carts out there, and we'll have collisions between carts, and we'll measure the velocities, and then we'll see how the momentum was conserved or not. So again, as far as it goes, there's not as much big stuff in this one, so you will see that this topic area will go quick. I did want to just highlight a couple of things. So I'm just going to switch over here to our topic set 6, and you can kind of see that we're going to look at a number of different things. Since this is going to be a short video, you may want to go through and do both the web resource and the reading. Now the reading is on the physics of billiards, okay, so in other words we're looking at pool balls and how to kind of sink the 8 ball. And so it does talk about some basics of momentum, and I think that's a good one to kind of talk about. The other one that I would go to is this web resources. For those of you that especially like the superhero stuff, you're going to look at this in terms of Spider-Man and the amount of momentum in trying to catch somebody, and so that's going to be kind of an interesting little video. Okay, so that's a little video, and that one's kind of a little reading. I'd suggest doing both of those because, like I said, this isn't going to be an overly long video. All right, so check those out, and we will see you on Monday, I believe. Monday. All right.